Hello everyone, my name is Partha and today I am going to walk you through the fascinating story of how Bayesian probability, a statistical principle at the heart of AI and data science, originated from a blend of faith, philosophy, and mathematics. We will explore how two 18th century thinkers, Thomas Bayes and Richard Price, used religious and philosophical ideas to shape a concept that now powers some of the world's most advanced technologies. Let's begin with the basics. Bayesian probability is a method of reasoning that updates the probability of a hypothesis as a more evidence becomes available. It uses Bayes' theorem, which says posterior probability equals prior probability times the likelihood divided by the evidence. This might sound technical, but it's the backbone of how systems like spam filters, medical diagnostics tools, and even self driving cars make decisions. They begin with assumptions, take in new data, and refine their beliefs just like a human would. Now let's rewind the 1700s. The Thomas Bayes was a Presbyterian minister and a self taught mathematician. His friend Richard Price was a philosopher, theologian, and political thinker. They lived during the Enlightenment, a time of radical new ideas about reason, science, and faith. But it was also the Great Awakening, a period of religious revival. This dual context deeply influenced their thinking. Their work was just about numbers, it was about reconciling a divinely ordered universe with human reason. Bayes once said, God governs the world by general laws. For him, probability wasn't random, it was a reflection of divine order. Price, who published Bayes' work after his death, wrote, the more we see of chance, the more we see of providence. Their Christian beliefs didn't compete with science, they inspired it. They believed that the natural world followed laws set by God, and that discovering those laws was a way to better understand the Creator. In that sense, mathematics became a spiritual exercise. In 1763, Price published Bayes' groundbreaking essay titled An Essay Towards a Solving Problem in the Doctrine of Chances. This essay introduced the idea of inverse probability, asking not just what are the chances of this happening, but also given this result, what's like the cause. Bayes used a thought experiment with drawing balls from a box to illustrate this. Price expand on it, connecting the logic of cause and effect to a theological vision of divine interface. This became a foundational idea in statistics and inference. Fast forward to today. Bayesian thinking powers much of modern artificial intelligence. Now let's see the three examples of Bayesian probability in modern technologies. Bayesian inference is commonly used in spam filters. Here's how the components work. What is prior? Here. Assume that email has a 50-50 chance of being spam or not. And what is the evidence? Certain words like free, win, or limited time occur most frequently in spam. A likelihood here, based on the past data, calculate how likely those words appear in spam versus non-spam. Posterior, update the probability of spam using Bayes' theorem. If the evidence strongly supports spam, the posterior probability increases. Look at this diagram. This shows how the probability of email in spam from 0 to 1 on x-axis, and on y-axis you see the probability density. By looking at the graph, this shows how the prior, likelihood, and posterior evolve through Bayesian updating. Let's move to the second example, medical diagnosis, a disease prediction. Bayes' theorem helps interpret diagnostic test results, especially when the disease is rare. Let's say the prior disease prevalence was like data from 1 to 1000. Take the evidence as a patient receives a positive test result. And what is the likelihood here? Consider the test sensitivity, true positive rate, and specificity, true negative rate. Bayesian calculation tells us how likely the patient actually has the disease given the positive test. Now let's look at the tree structure. Now, Based on the prevalence, the data shows how many actual have the disease. Now split into true positives and false positives based on the test characteristic. Now these false positives may outnumber true positives if the disease is rare, emphasizing the importance of the prior. Now let's see the third example in the machine learning, a naive-based classifier. This algorithm is widely used for classification problems in machine learning. Applications like sentimental analysis, for example, a movie review, whether it's a positive or a negative. News categorization, example, assigning an article to sports, politics, or tech. Each feature contributes to the likelihood of a class. Assume features are independent, hence naive. Now use this formula. This method allows fast and effective classification even with simple assumptions. Here is a powerful way to visualize this intellectual journey. First, there was a faith in divine order that inspired philosophical reasoning, asking how we can understand that order. This gave the birth to mathematical formalism like Bayes' theorem. And today, those ideas form the foundation of AI models that shape how machines learn. It's a remarkable chain of thought that shows how faith, logic, and science can work together, not against each other. To conclude, Bayesian probability is more than a formula. It is a product of an era where spiritual belief and scientific reasoning were deeply intertwined. Thomas Bayes and Richard Price were not only statisticians, they were philosophers and theologians who sought to understand the universe through both divine insight and rational evidence. Today, their legacy lives on every email filter, medical algorithm, and artificial intelligence decision engine we use. Faith and reason didn't just coexist, they co created one of the most important tools in modern science. For those who are interested in further reading, here are the primary sources I referenced include Bayes' original 1763 essay and works by Price, Dale, and others. Yeah, thank you.